Right, state the Morpham's theorem and use it to express cos for A as a polynomial. Okay, so the Morpham's theorem says cos theta plus I, or well, maybe I should use A. Cos A plus I sine A power 4 is equal to cos for A plus I, well, I guess it's not 4, it's N. Then I'll make it equal to 4. Okay, cos A plus I sine A power N. Yeah, that's the Morpham's theorem. Now what we'll do is we'll set N is equal to 4. So that becomes cos power 4A plus 4 cos cubed A sine A with I plus 6 I squared cos squared sine squared A plus 4 I cubed cos A sine cubed A plus I 4 sine power 4A equals the right hand side. So we're just looking for the cos for A, so we just need to look at the reals. So that means cos for A minus 6 cos squared A sine squared A plus sine for A equals cos for A. So that's cos power 4 minus 6 cos squared, and sine squared is 1 minus cos squared, and then that's going to be sine squared squared, so that's 1 minus cos squared squared is equal to cos 4A. So that means cos 4A will equal cos power 4 minus 6 cos squared plus 6 cos power 4. Cos power 4 minus 6 cos squared plus 6 cos power 4 plus 1 minus 2 cos squared plus cos power 4. So that's 8 cos power 4A minus 8 cos squared A plus 1 cos 4 cos 4 and then 6 of them there, so that's 8 of them. Minus 6 minus 2 is minus 8 of them. And then it's 1. One way we can check is if we put in like an angle, like 10 degrees or something, we can check that the formula works. So 8 cos 10 power 4 minus 8 cos 10 squared plus 1. Okay, that's 0.766. Cos 40 is 0.766. Yep, so that story checks out. So that's A done. Complete the following sentence. If the complex roots of the equation are conjugates, then the coefficients all belong to the set of real numbers. This is the complex conjugate root theorem. Okay. Next, show that I is a root of that equation. So I cubed minus I squared, well, straight away they cancel, minus I plus I equals 0. Yeah, I cubed minus I plus I equals 0. And find the other two roots. Could we factorize it? Z minus I. No, we'll do a long division. I don't think it'll be too bad. So Z minus I divided into Z cubed minus I Z squared minus Z plus 1 equals 0. So that's Z squared. That becomes Z cubed minus I Z squared. They cancel. That becomes minus Z plus 1. So that becomes minus 1. So that becomes minus I. Oh, that's an I. Minus Z plus I. Yeah, okay. So they are plus or minus 1. So it's I, 1, and minus 1 then. So they're the other roots there. Okay, so that's okay. We have omega and Z, and omega is that. Okay, so omega is 3 minus 2Z. Omega is U plus IV. That's 3 minus 2X plus IY. That's U plus IV equals 3 minus 2X plus minus 2YI. So that means U is equal to 3 minus 2X and V is equal to minus 2Y. Find an equation in U and V which corresponds to X equal to Y. So here I can say U minus 3 equals minus 2X and V equals minus 2Y. So dividing by minus 2 and making them equal, and then cancelling the minus 2, I get U minus 3 equals V. On the Argand diagram, plot this, and then on the other one, plot the transformation we just did. So there's the first one, passing through 1 plus I, and that's at 0, 0. I'm just doing this quickly. And then the second one, when you transform it, that's V equals U minus 3. So it'll be down here at minus 3I, but it'll still have a slope of 1. So it will cross here at 3. Yeah. Okay.